How to repair a Birmingham Dribbler. This is part 3. Reprofiling the cylinders and port faces using wet or dry sandpaper and some WD-40. Carefully quartering and fitting the driving wheels using Loctite 603 to secure the wheels to the axles. Just to recap, a Birmingham Dribbler is a very small steam locomotive. This is a reproduction of a Victorian toy. It was called a dribbler because that's what they used to do as they ran around the floor. These engines were never designed to run on railway tracks. But if you tighten the bolts on the steering and lock the front axle in position, it would run on a track because it is gauge 3 or 2.5-inch gauge. The small locomotive is deceptively powerful, as you will find out when I start to run it. Hopefully I will run the engine at the end of the episode. But first I need to reprofile the ports on the cylinders because they are very badly scored. For this, first of all, I'm using 400 grit wet or dry sandpaper, followed by 600 grit wet or dry sandpaper. And as a lubricant, I'm using WD-40 because it makes the sandpaper cut a lot better. Here's a second cylinder having the same treatment. It took a while, but in the end I got a perfect finish on the ports. I don't know why the ports were so rough in the first place, because when I first bought this engine it was new. But now, thanks to this stuff, the ports are as good as they were on the day I bought it, as can clearly be seen from this image. It looks to me like these blocks are castings, because if you look carefully you'll see they are rough around the edges. At first I wondered what this damage was, then I looked carefully, and here when I put them both together, you can see here that the unevenness is the same on both cylinders. And this is one of the port faces in the main casting. This is not very good either, especially as I didn't run the engine much before the axle fell off. When I turn the bed casting over, you can see that the other side isn't quite as bad, but both of these need reprofiling to match the cylinders. With the main bed casting, I had to be careful to make sure it was straight and level before I started grinding away the face. I was applying plenty of pressure on the inside front of the casting, just above the port face. And this, in conjunction with the protrusion at the rear of the casting, made it a very simple job, not quick but simple. First of all, I removed the marks using 400 grade wet or dry sandpaper, followed by 600 grade wet or dry sandpaper. And when I was using the finer wet or dry sandpaper, I even rubbed the top part of the casting. This part of the job is now complete, and I'm going to fit the main wheel set. Using Loctite 603, I can already hear some viewers going, "Oh no, not a retainer, that's no good at all," on a very small toy steam engine. But in this case it's perfect for the job. The diameter of the axle that fits into the end of the wheel is less than 3/16 of an inch. I fitted the first axle being very careful not to get any Loctite 603 into the threaded hole. And here I'm tightening the 5BA countersunk bolt. Now to move to the other end, and more Loctite 603 is needed, but this end is different. Have a close look at the register on the end of it. The axle has been machined to the correct diameter to fit into the wheel, but it's not the same length as the other axle. If you've been watching the series, you will know that this axle is one of the front axles. I used the replacement axle that I made from stainless steel for the front because it's visible and it looks better. Same as before, although this time the axle is through the main bearings, I applied some Loctite 603 to the outer part. Once again, being very careful not to get any into the threaded part. What I need to do now before the Loctite 603 sets at this end is quarter the wheels. This was a very simple job, and this is how I did it. Well, no it isn't really, I did it by eye. I just used the screwdriver to check that everything was okay. It is essential that the wheels are quartered, with the positions of the crank pins being at 90 degrees to each other. Luckily, one of my screwdrivers was just the correct diameter to slide through, and confirm that the crank pins were in fact at 90 degrees to each other, which is what I wanted. At this stage I needed to let some time elapse so the Loctite 603 could cure. And once it had cured and the wheels were very rigidly set on the axle, this was tested by trying to twist the wheels and they wouldn't move. Before I forget, I'm going to put some oil into the inlet to the cylinders. This is where the steam pipe from the boiler connects. This job was a bit odd. I'm refitting the bolts that hold the springs, which in turn hold the cylinders against the port face. Caution, don't over-tighten this bolt. If it snaps off, you do have a big problem. What I'm doing here is rigging a temporary air connection so I can give the engine a test run. Because this is a twin-cylinder engine, I expected it to leap into life the minute I connected the air, but this was not the case. I had to give it a push. It runs well at high speed and low speed, and there's plenty of power. What I'm doing here is running in the port faces that I've just lapped. I run the engine slowly and fast with plenty of oil. And as you can hear, it sounds very sweet. I'll stop talking so you can hear it. There's certainly plenty of power. I'm turning it over to look underneath just to make sure that the trunnion pins or brass bolts haven't worked loose. I think I can tick the box which says this part of the job has now been completed. In the next episode I will be fitting the front wheels and the boiler, and that's where the fun begins. Until then, stay safe, stay healthy, thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.